Hello everybody, my name is Debashish. I'm the senior network trainer as well as Cisco networking specialist at the Indian Cyber Security Solutions. And these are my contact informations for LinkedIn and Twitter. Today I'm going to discuss about DMVPN, Dynamic Multipoint VPN. Now DMVPN is a VPN technology where all the sites communicate with each other just like normal VPN. But we do not need to statically configure all the sites to communicate with each other. VPN, this is also a VPN technology which is known for security purpose for a very secure connection between sites. But here all the sites need not to be manually configured each time because DMVPN uses hub and spoke topology. So one router is hub router and the other clients, other locations are connected through the hub router in a hub and spoke topology fashion. Spoke routers communicate with themselves without accessing hub router. So this is a unique feature of DMVPN that spoke routers can directly communicate with each other without the need to access the hub router. And encryption is supported by IPsec protocol if needed. Next is NHRP, Next Hop Resolution Protocol, that is used in this dynamic multipoint VPN technology. Here, spoke routers resolve public IP addresses of other spokes by NHRP protocol. The NHRP process can be described as the one router will be the NHRP server, that is the hub router. Okay, all other routers will be NHRP clients, means the spoke routers will be NHRP clients. The NHRP clients register themselves with the NHRP server and report their public IP addresses. The NHRP server keeps track of all public addresses in its cache, so it stores the public addresses in its cache. And when one router wants to tunnel to any other router, say one spoke router wants to tunnel to any other router, it will request the NHRP server for the public IP address of the other router. So actually what happens that the NHRP spokes, they request the NHRP server, means the hub router, for address resolution, the public address resolution, and NHRP hub or the NHRP server redirects the request, redirects the resolution message, public address resolution message to the spokes, and after that spokes build a tunnel between themselves without consulting the hub router. Now there are three phases of DMVPN. Phase 1, we see spokes register with hub using NHRP. First step is spoke routers or clients will register their addresses, public addresses as well as non-broadcast multiple access addresses with the NHRP hub. Spokes use point-to-multipoint GRE-TINE interface as usual. There is no direct spoke-to-spoke communication in case of phase 1. So all the communication happens through the hub router. In phase 2, spoke routers establish direct spoke-to-spoke tunnel and they send NHRP resolution request that I was telling you. They send spoke routers send NHRP resolution request for the public address to the hub to find NBMA address of other spoke. And in phase 3, hub sends NHRP redirect message, redirect request to spoke routers, informing them about the NBMA address of other spoke routers, and after that spokes use NHRP resolution to find out NBMA address of other spoke, and when they have find out the NBMA address of other spoke by NHRP resolution, then they can form the DMVPN tunnel between themselves without consulting the hub router. So that is the advantage of DMVPN, the direct communication between the spoke routers, ignoring the hub. So that is about the theory part, and now I'm going to show you how to configure the DMVPN part in GNSC simulator. So say for example, R1 is a hub router and R2 and R3 both are spoke routers, and we are going to configure the phase 3 DMVPN configuration means the final configuration for the DMVPN, where these R2 and R3 routers will actually build a DMVPN tunnel between themselves, ignoring the hub router R1. On the hub router R1, let's do the configuration first. Let's create an loopback interface. Say 1111. And go to interface tunnel 0. Provide an IP address. Now this is a tunnel IP address, means a public IP address. Remember this thing. Now I give the command no IP redirects. Means what? I'm not going to send the TCP redirect message to the client, but I'm going to send the NHRP redirect message to the client. Then you can configure authentication also. And for authentication, you can give any key value. I'm giving, say, DMVPN. So this would be same in all the client routers as well. Then you give the command IP NHRP map, multicast, and dynamic. What does it mean? Means that the hub router will send multicast requests to the clients, and it will dynamically learn the public addresses and NBM addresses of the clients. Then IP and HRP network ID, have to give one network ID. Say the network ID is 1, it should be equal in all the clients as well as on the hub. Then IP and HRP, this time redirect. So when the clients or spokes will request for the IP and HRP redirect message, then it will respond, and the hub router will send the NBMA address to the clients. Then the tunnel source, you have to specify the multi-point tunnel source. That should be the fastnet port that is connected. And tunnel mode, GRE over multi-point. We are using GRE protocol over multi-point tunnel. And now you give the NBMA address on the fastnet port. Say 192.168.123.1. So this was the configuration for the hub router. Save this. Now you go to the spoke router, say on R2. You create a loopback interface 2.2.2.2. Go to tunnel interface. IP address is 172.16.123.2. No IP redirect. Then the authentication. that is DMVPN. Then you are mapping the hub router's public address to its NVMe address. Public address, that is 172.16.123.1 to 192.168.123.1. That is the fastest that port's NVMe address. Then IP, NHRP, map, multicast. So it will send a multicast request also, and for multicast, the NVMe address will be used, not the public IP. Remember. Then the network ID, and then IP, NHRP, and then the server, the hub router's IP. NHS means the hub router's IP. This is very important. That this should be the public address, not the NVMe address. Then you give the command IP NHRP shortcut. Now what is that? If you give the command, this command, then the spoke routers will directly communicate with other spoke routers by building the DMVPN tunnel between themselves. That is why it is shortcut. Means it's going to avoid the hub router. Then the GI tunnel source is faster than port 0 by 0 of this router also. Tunnel mode is GRE multipoint. And you give the NVMe address to the Ethernet port. Say 192.168 and 123.2. And that's the configuration for the client 2. Just save this. And now go to client 3. Same way, you create an loopback IP. Say 3333. Go to tunnel 0. Give the tunnel IP address, public IP as 172.16. Say 123.3 this time. No IP redirects. IP NHRP, then the authentication, and the same key, that is DMVPN. And you should map the public IP to its NVMe address of the hub router. That is the same thing. 172.16.123.1. I would map to the NVMe address of 192.168.123.1. Then the IP NHRP map, and then multicast target, that is also the NVMe address of the hub router 192.168.123.1, and the network ID 1. Then the IP NHRP NHS, and the hub routers public IP should be specified just as in the case on the R2. And then IP NHRP shortcut. Multipoint tunnel source should be fast Ethernet port of this router. Tunnel mode should be GRE for multipoint. And the IP address of the fast Ethernet port, the NVMe address would be 192, say 168.123.3 this time. And save this. So you have configured every router, and now check. You give the command show DMVPN. You can see both the clients or the peers or the spokes IP address, that is this NVMe address as well as the public address, so the tunnel is up, and you can ping both the addresses. Say the public addresses, okay. And now if you go to the R2, and if the R2 give this command show DMVPN, now it has a hub router as its peer. Now if it's going to ping the address of the R3, that is a 172.16.123.3, yes, just ping. And if you give this command trace route, then 172.16.123.3, that is the public address of the R3 spoke router. And see, it has already made the tunnel to the R3 directly. So the request is not going through the hub router, it is going straight to the 172.16.123.3 Mr. R3. So it has already made the DMVPN tunnel directly, ignoring the hub router. So that is the beauty of DMVPN. So I hope you have understood it. I hope it was informative for you. And if it's informative for you, then you please like and subscribe our channel on YouTube. So that's it for now. We'll meet with some other topics some other day. Till then, goodbye.